Hey YouTube, XCT here. Today I'm going to show how to solve a machine called Store on Vulnlab. This is one of the few machines that involve a bit of web exploitation in the beginning, but the main focus is around how we can use various debugging ports to our advantage. Alright, as always we are starting with a port scan, and you can see that besides SSH there are a couple of high ports here which are all Node.js. So let's go there in a browser like this. And if we go to another one, it's just the same application. So it's just multiple instances of this application. It's telling us it's storing stuff encrypted. So it's even mentioning military grade encryption. So it must be really good, right? We can list files and upload files. So let's actually try to upload one. Just going to create a simple file here. We do just a couple of A's and put them into a text file. And then I'm just going to upload the text file. All right. And then if we go to list, we can see the file here and the file contents. So far, so good. Now we have to look for vulnerabilities. Another thing we can do before we actually dive in a bit deeper is to just fuzz the application. Like with web applications, that's I think always a good idea. So we do it like this. Just do fuzz here, and then I'm giving it derived small directories word list from sec lists just to see if there's anything in the web root we can't see yet, right? All right, we can already stop this. CSS temp images upload list. If we go here into burp, the only thing I really can't see here is temp. So this must be something that's not directly linked in the web application. And if we go here, okay, we can't really get it, but maybe we can get our file here that we just uploaded. And this seems to work, right? So this seems to be another way to retrieve the file, but the file content is somehow broken. If you remember the start page here, telling us it's encrypted storage, right? So we can assume that if we go to a file here in the web application, that this is decrypted for us, but the actual file on disk is stored encrypted. And this is kind of what we see here if we get this file. What we just saw, right? That was just the encrypted bytes. We don't really know how this file is encrypted, but we could maybe find out. We sent a couple of A's, right? And of course there's an almost infinite amount of possibilities how to encrypt this. But the very simple thing that's often used is XOR. So we could try and see if this is actually XORed with something. Because, well, we know the clear text, right? We sent this and then we got back this file from TMP, which had some random bytes. I can just do curl here like this. So these A's somehow got encrypted to these bytes. If this is XOR, well, we could just XOR the clear text file to these bytes and would get the key, right? So let's actually try that out. So I put the bytes here that we got from the curl. I put the A's here, which was the file content. And if we XOR this, we get some clear text back. And this is actually the key. And you can see that this is just repeating here. So this is the first. It's the same as the first bit here, right? So this is just an XOR key that's repeated for the full length and XOR to the clear text. Okay, so we now know the XOR key. And if we use XOR tool, which you can just pip install like this. I already have it, so I don't need to do it. But if you don't have it, you can do it like this. Then we should be able to do this curl again. Like this. This would give the encrypted file, right? And then we should be able to do XOR tool, XOR S, and then we give it the key. And then we're telling it to take data from standard in. All right, and now we decrypted it on the fly by XORing it. So just to make it clear, this gives random bytes. But if we XOR it with the key we just obtained, we get the clear text back. All right, so this is pretty interesting, but it's not helping us too much yet. But we kind of figured out how these files are encrypted. All right, so we can now decrypt the files that we find in temp. And one way would be to fuzz the temp directory, but I can tell you there are no other files in there at the moment. So it's completely empty. There's nothing to decrypt. So what we kind of want to do is find a vulnerability. Ideally, we want to find something like an LFI vulnerability, because we just learned the application is encrypting files it serves, but we can decrypt them, right? So it would be great if we could just like put something like this here. That would be great, but it doesn't work. And I'm going to show you how this actually looks on the machine. So this is the source code of this particular route. And if we look here, this file endpoint has a file parameter. This is what we saw on the URL. And then it grabs this as name. And then it just concatenates it to the current directory. This is the temp directory we saw here, and just puts the name here. So whatever we put there as a file name is looked for in the temp directory. But it kind of looks like ... something would get us one directory up, right? There's one function here which kind of looks like it's preventing this, but it's actually not. If we look for path normalize here in the node documentation, it mentions these dots, but normalization doesn't mean it prevents any vulnerability, because if you look here, this is the fifth ... and it resolves to, let me see, yeah, this here, right? So it just moves one directory up, it executes the dots, if you will. So this is actually not preventing anything. And it's then downloading the file, XORing the file contents, and serving it back to us as base64. All right, so this is technically vulnerable for path traversal by giving it like ... sequences, right? But it kind of didn't work in the URL. So what we'll have to do is, let's just go here, then send this to the repeater. And then what we want is basically go back like this, right? And we actually, because it's in a URL, have the URL encoded. So we can give it here to the decoder to encode as URL and get the string here. Then we replace this here. Now the whole thing we entered is URL encoded. And now we actually get the contents back. So it's exactly like we saw in the code. This is vulnerable to a path traversal, to a local file inclusion if you wish, because it just downloads the file we give it here. We just have to URL encode the parameter. And this is not so uncommon in Node applications, and something to keep in mind. Okay, so we get the encrypted file here. But remember, we actually know how to decrypt it, right? We just have to XOR it with the key. Right, another thing we can do is we can actually also send this as a post request, because the source allows this. This is like particular to the application. So there's a post route and a get route, but they are kind of the same. It's not really a big difference. And instead of doing it in burp, I'm going to do it with curl here, because that's a bit easier to see. Basically, we do it like this. We post to the file endpoint. We give it the file name here. And because it's a post request, we don't have the URL encoded here. If you were to do it with a GET request, you have the URL encoded. All right, and if we get this to XXD, we actually get the encrypted contents here, right? Curl is just not showing them if you like don't pipe them to XXD here. Okay, but it's still encrypted. But we already saw how to decrypt it, right? So we do XOR to XOR, give it the key here, and then standard in, and we can actually read files on the system. All right, so we got a proper LFI here. What kind of files could we read now? Well, one of the files I always like to read is proc self command line, because you like see how the program was started. And in this case, it's pretty interesting because, well, it's a Node app, we already know that, but it also has this -- inspect parameter, and this is actually opening up a debug port. So if we were to connect to this port, we could probably execute arbitrary JavaScript. So that is really useful. Also, what this tells us is where the application is stored. So we can get this path here. So let's try to read the application files, right? That's also always interesting. So instead of this, we do home dev projects store1, and then maybe start.js. All right, not too interesting. You can do app.js, that's like default. Also not too interesting. So another file that often exists with Node is the .environment file or .env file. And this is actually used here. And we can see the secret here. That's the XOR key, right? It's the same we found here. And we also see that this is using SFTP somehow, and there are SFTP credentials here. All right. So SFTP is giving you file access in the end via SSH. So we should be able to just use this, I think. Let's actually try that. SFTP and then SFTP user at store.bl. All right, we give it this password here. And this seems to work. We have a files directory here. And there's only the file we uploaded. So it's not helping us too much. It seems like this application is basically storing these encrypted files on SFTP internally instead of just a local folder. All right. But one other thing that's sometimes possible when you have SFTP is forwarding ports. It depends a bit on the SSHD config, but sometimes it's possible. So we could just like LFI the config to check it, right? But it can also just like try it. So I'm telling it to not open a shell here. And then let me just copy that. We do a local port forward of this debugging port. We just saw this one, right? And forward it to our local machine on the exact same port. Okay, let me see. There was an issue here. Oh yeah, we have to do actually SSH here, not SFTP. And then give it the password. All right, and now if it worked, we should have the port listening on our machine here. Yeah, here we go. Okay, so this is this node inspect debugging port here. So let's actually check out what we can do with this port. So if you go once again here to the node documentation, security implications of the debugging port, and you can see it's the same port number, right? So this is kind of default. Exposing the debug port publicly is unsafe. What does it tell? Local applications have full access to the inspector. So this essentially means that we can execute arbitrary JavaScript code in context of the application if we connect to the debugging port. And it's actually the developer is doing what he's supposed to do, right? He's only using it on localhost, but we have a way to reach this port via the SFTP. All right, so how do we actually exploit anything here? Well, we can attach a debugger, right? And if we go to the Visual Studio documentation here, we can see that you basically need a launch.json file with this content, and you just give it the IP and the port, and then you can attach to the application. So I already created this file here. Essentially, you just copy paste it. You go here to this debugging thing, and then it can generate the file for you. You paste the contents from the blog post, which is basically address and port here, right? And then if you have this launch.json file, you just click this arrow thingy here, and you should be able to attach. And of course, we have to target localhost here because we forwarded to the port, right? All right, let's see. This looks an awful lot like the LFI attempts we had, right? It's basically logging them to standard out, and now we can see the standard out of the process. So this is really, really useful for us. Now we should be able to execute just like any node code that we want. And of course, we can just like grab a shell script from our machine, execute it, and get a shell. And that's essentially what I'm going to do. I'm just going to grab a script here. We do require shell process, execute wget on our IP, and this X file is, as always, this resh.py file I generate, which just tries different reverse shells, right? And here we can see we get the request. That just happened. Then let's open a listener here. And the only other thing we have to do is really to execute the shell script we just downloaded. So I'm again doing require shell process, execute, and then sh or bash on the shell script, right? All right. And we actually get a shell here as the user developer. And if we go to the home folder, we can read the first flag here if we want to. And in projects, there is the application we just saw. Now there's a checkpoint here. If you go to SSH, we get a SSH private key here, which we can use to connect to the machine. So you don't have to re-exploit this all the time. You can just grab the key and then work on root. All right. So I'm actually going to connect here via SSH now. And now we can have a look at how root could maybe look like, right? So I'm doing a PS here, and essentially we see the node application listening 3 times here. Why is it listening 3 times? Well, that's just, it's a developer running it, right? And for like technical reasons, this is just if one of the application crashes, you always have 2 other. All right, that's not really important for the root step. Okay, there's no real process here that looks too interesting. Let's do a net stat, maybe there's something else. And there actually is. So there's this port here, 9515. If you just like Google for this port, right, you find Selenium and WebDriver. This port is actually used by the ChromeDriver. So what's that? It's essentially a way to programmatically control a browser, and is sometimes used by developers, for example, to check stuff, to browse to websites, to click links, to just do stuff that a browser can do, right? And on this machine, it's also used. And this is actually running as root. All right, so what can you do with this port? Well, it allows you to create a session. You send a certain web request to the port, and then you get a session that you can then use to like browse to websites, read files, and so on. Not only can you create a session, you can also give parameters to it. Parameters to the Chrome that will be starting up. And there's an article here about debugging this. And this shows some of the parameters you can use. It's not like the full documentation, but yeah, some of the parameters, right? There's no sandbox. It's mentioning a couple of them that are useful for debugging. And one thing, yeah, it's this one here, is you can debug the renderer, and you can basically give the renderer CMD prefix. And this is just like something that will be executed when Chrome starts up. So this is ideal, right? Because we could just create a session with this parameter, and then when Chrome starts up, it would execute whatever we put here. And in fact, this was also like an unintended solution to a binary exploitation challenge on Hack the Box a while back, because you could basically have influence over the command line of the starting Chrome and just give it this render prefix, put a shell script here or command, and then execute it. All right, so what are we going to put here? I'm just going to create an MSF Venom shell here and get a reverse shell. Okay, so first of all, let's create this reverse shell. Just like this, right? Linux x64 shell reverse TCP. I'm storing it in my .deb folder here. This is where I have my web server running. Then we go to temp here and just pull the file over. So just like this, chmod on it. And then we can test if this reverse shell actually works before we exploit anything. Yeah, this looks good, right? So this is actually working. Now let's interact with this port. Well, really all we have to do is to send a crafted curl request that creates the session with the parameter. And it's going to look like this. Let me paste this here. You can find a bit of documentation on this, but it's actually kind of annoying to find. So I'm just going to give you the curl command so you can put it in your notes. Basically, this creates a session. You say the browser is called Chrome, and you give it a couple of arguments. I think you need the headless and no sandbox arguments. This is like something you always want to do. This one as well, I think, I'm not 100% sure, but this one is the one we just saw in the documentation that will execute when Chrome starts up, right? It's just running our binary then. And all we really have to do is post this to the session endpoint on this port. So if I do this here, it should hang for a bit and then we should get a shell. And we are root. We can go to directory here and read the final flag. All right, that's it for the machine. Why is this useful? Well, as soon as you see this port, you know how to exploit it now. And also like, this is not too uncommon with like at least CTF's machine and stuff like that. Maybe Hack the Box, Strike Me and all of that, because if you have XSS automation, you often are using the WebDriver and this port is sometimes open. So this is like an easy way to escalate privileges. Of course, it's usually not intended, but often the authors leave it open and then you can exploit it. All right, so that's it from my side. If you want to check out the labs, go to vulnlab.com. You can subscribe there and then you get access to a vulnerable machine lab. We have about, I think, 55 to 60 different vulnerable machines now. And yeah, see you next time.